Welcome to NTWC Live. My name is Alex Garcia. I'm the director of the National Tropical Weather Conference. These programs are made possible by USAA, South Padre Island Convention and Visitors Bureau, and Plylock's Hurricane Clips. To produce these programs, it's a team effort. We have Bill Reed and Tim Smith with us this morning. Here's Tim Smith.
NTWC Live. Thank you, Alex. It's good to see some people on board with us again this morning. Yesterday I was at South Padre Island. Maybe you can see the sunburn here. I can change that so it looks like I'm at South Padre Island. There we go. How about that? So at least we can pretend to be there. But it's good to see so many people on this morning, and I think we've got a great program for you today. As Alex mentioned, Plylocks, USAA, and the South Padre Island Convention and Visitors Bureau make these programs possible, and that's why we're out there as often as we can be. And they are open and doing well, and they're expecting, I saw yesterday, 50,000 people socially distanced for the Memorial Day weekend. We'll see how that goes. Population out there is about 3,000, so we'll see how it goes. Got a great program for you today. For the details, let's turn it over to Mr. Bill Reed, former director of the National Hurricane Center. Bill, good morning.
Good morning, Tim, and everybody else out there. 10 days now to the official start of hurricane season, though we already cracked the door open a little bit with Tropical Storm Martha the past week. Today, there's nothing going on in the northern hemisphere. However, a new storm has formed just to the west of Indonesia in the southern hemisphere, heading southeast towards the west coast of Australia. Joint Typhoon Warning Center currently holds it at tropical storm intensity through the next 5 days. Probably should have had Alex play a little bit of the Doors' Riders on the Storm for today's speaker's intro. We back by popular demand. We have Ryan Rickert and Garrett Black from the 53rd Weather Reconnaissance Squadron, most commonly known as the Hurricane Hunters. They're going to describe their mission and give us a little bit of show and tell on what it was like flying into Dorian. So I hope everybody took their Dramamine. Take it away, guys.
Well, thanks, Bill, Alex, and Tim. Garrett and I are here today, and we're really excited to share a little bit about what we do. A couple weeks ago, Eric Blake spoke a little bit about why our mission is important and the aircraft reconnaissance piece and the data that they collect. But today, we're going to kind of share a little bit about what it's like to actually fly through hurricanes like that, and a little bit about what we do outside of hurricane season, because a lot of people probably think that we don't do that much and we sit around on our chairs or whatever, but we actually have quite a bit busy year every year with going from hurricanes and tropical systems to winter season storms that we fly, and they're basically called atmospheric rivers. So I'm going to try to share my screen here, and we're going to go into the brief. We have about 40 slides. We're going to try to go through them a little quick, so that way you guys have an opportunity to ask a lot of questions if you have. So share screen. You all let me know if you see our slides.
There you go.
We do.
Okay, great. So like Bill introduced us, we're the world famous Hurricane Hunters. My name is Lieutenant Colonel Ryan Rickert, and we have Captain Garrett Black. Go ahead, Garrett.
All right. Well, first off, so a little bit about our history and how we even became to get into this mission and to fly into hurricanes. So it actually began on a barbette back in 1943. So World War II time period, obviously. And it was a barbette in Texas, of all places. So we had our pilot here, Joe Duckworth, was sitting at a bar with a lot of British airmen. And they were giving him a hard time about the T-6 aircraft not being up to the capabilities and standards of maybe different aircraft that the British were flying at the time. So pilot Joe Duckworth knew that there was some weather going on out in the Gulf of Mexico. And so he grabbed his navigator there, O'Hare, and they jumped in the T-6, flew out into the Gulf and flew through the eye, and then turned around and flew right back into Texas, and went back to the bar, was bragging to all of his buddies. And the weather officer there, Jones Burdick pictured, was overhearing this and was like, this could be, a big breakthrough in the scientific and meteorological community. So he asked the pilot if they could go back out there with him in the back seat, and did, and started figuring out the exact latitude and longitude, location, strength of the storm. And that's kind of how the hurricane hunting mission began. And here's a side-by-side comparison. So you can see we've obviously come a long ways since 1943 as far as aircraft that we fly into hurricanes. So we have the T6 pictured there up next to our WC-130J, which we currently fly into tropical systems. So the way we operate is off of a document called the NHOP, or the National Hurricane Ops Plan. And every year this is reviewed amongst the Department of Defense, Air Force, and the Department of Commerce, typically the National Hurricane Center, as well as other government entities that kind of come in, and we come up the requirements of what we need to do to consider our mission a success, and different requirements that we may need. And so kind of the big nuts and bolts of it is that we have to obviously be able to operate 24 hours a day, and we have to be able to fly 3 storms at a single time from 3 different locations. And so that kind of sets the bar for us to figure out how we need to get the logistics in place so we can support this requirement. And we only have a 16-hour immediate response, so it's a relatively quick turnaround. So getting the logistic pieces, personnel and equipment into the right areas to be able to accomplish this is something that takes practice, and make sure that we're ready to go. All right, so on board, we have 5 personnel, typically for a minimum mission. So we have 2 pilots up front, an aircraft commander and a co-pilot. And then we have a navigator that also sits up front, and they're typically running the radar and the fuel requirements, making sure that we're being safe in that aspect, but also doing a lot of the radar, really, and making sure that we stay out of the worst of the storms. So we obviously try to fly and gather the most important data and the most critical parts of the storm. But if we see different types of, say, hook echoes or different V notches that could signal tornadoes, we try to steer clear of those, obviously, because that's not ideal to fly through. And so that's primarily what the navigator is doing. In the back of the aircraft here, we have the load master, the drop son operator. So they're actually the ones that release the drop sons that we'll talk a little bit more about here in a bit. And they're doing a lot of the quality control on that data before they send it over to the ARWO, or the Aerial Reconnaissance Weather Officer, which is what Lieutenant Colonel Rickert and myself do. And here you can see kind of our little setup and station. It's right next to the loadmaster in the back of the aircraft in the cargo compartment. And that's where our data is kind of streaming through and where we're working. So as far as our area of responsibility, it's pretty known that we fly a lot of Atlantic and Gulf of Mexico storms. We fly pretty far out in the Atlantic, actually, even when they're just little thunderstorms, clouds, or waves coming off the coast of Africa. Once it kind of crosses that line, 52.5 west, we'll start to investigate them if necessary, if the National Hurricane Center thinks that it may be a threat. But we also go way out in the Pacific, just about to the Hawaii Islands, a little past. So if any East Pacific storms or Central Pacific storms look like they may affect the coastline of Mexico or the Hawaiian Islands, we can forward deploy to get out there to be able to sample those storms as well. And we'll fly storms, whether they're going to be an impact to the United States or other countries as well, especially in the Caribbean. If it's going to be any threat to land in this red rectangle here, we will fly it. And these are the primary locations that we work out of. So obviously Keeser Air Force Base in Mississippi, but then you have St. Croix in the U.S. Virgin Islands, and then Barbers Point out of Hawaii. So I kind of mentioned the different waves or smaller storms that are coming off the coast of Africa when they're way out in the Atlantic. We call these low-level missions or low-level invests, and it's kind of when a storm is just beginning to form and the Hurricane Center doesn't know if there's true circulation or whether the winds meet the criteria to begin to name it, whether it's a tropical depression or tropical storm. So we'll actually go out and fly anywhere from 500 to 1,500 feet above the water. So here's some images. It's really close. It may sound high off the ground when we just talk about it, but when you're actually in the aircraft and you're over the water, it's very surprising how low that actually is. But it gives the RWOs, or the weather officers, a great perspective of what is going on the ocean surface. So we can begin to see waves and see what kind of even bubbles and colors are coming off the water to determine how strong the winds are and out of what direction. So we'll typically fly in different patterns, and we're looking for winds in all 4 quadrants Yeah, I think this next graphic here, perfect. So it shows the winds in all 4 quadrants there, and that's primarily what we're looking for. So we want winds in all 4 quadrants up to a certain level of wind speed, and that's what the National Hurricane Center is looking for. They're typically by far the trickiest missions, I would say. But our more known missions are obviously in the stronger storms, such as hurricanes here. And you can see what we call the alpha pattern. It pretty much puts an X through the eye of the storm, the center. And we'll obviously fly these at a little higher altitude just because of the intensity and severity of the storm. So anywhere from 5,000 to 10,000 feet is typically what we'll fly going into a hurricane. But you can see by flying this alpha pattern through the storm, you're getting a sample of all 4 of the quadrants. And that's really important too, to see the maximum radial extent that the winds are going, and that impacts storm surge very dramatically, and as far as how far up the coastline they need to issue watches and warnings. So understanding how big those wind fields go out from the center is very critical. But you're also getting 2 passes through the center of the storm here, and that obviously begins to get you a way where you can calculate and kind of extrapolate the direction that the storm is moving, as well as the speed that it's moving. So as far as the data that we're gathering while we're going through this storm, this is kind of the picture on the right here gives a good screenshot of what we're looking at on our computer. So in the top left figure there with a lot of the numbers and the message that has popped up and is displayed, that's where we can look at the 10-second and 30-second data that's coming in through the aircraft. So at flight level that we're flying, it's bringing in all this atmospheric information. And that's really important for us because it tells us what's going on outside that we're at. And it also gives us an indication whether the data is correct or not. So we're constantly watching and observing that and making sure that the data is as accurate as possible. So that's something we always have up, we're always looking at for quality control purposes. And then you can see the message that's displayed there. And that gives us the ability to actually communicate, pretty much text with the National Hurricane Center on what we're seeing, send the data through there, and then we can get feedback from them as well if they're seeing something on satellite that they would like us to check out. So it's our way of communication with the ground, if you will. And then, so we'll go to the dropson here. So this gives us kind of an inside look at the guts of the dropson, but really the most important things with it is it's gathering pressure, wind speed, wind direction, temperature, and dew point. So you can see here, the parachute kind of pops out of the top. So as soon as it leaves the aircraft, within 5 to 10 seconds, usually that parachute ejects, and immediately we're receiving data 3 times every second until that dropson hits the water. And this is just an image here of our load master releasing the dropson in the tube right back there. And so when we're ready to launch, it'll fire out of the bottom of the aircraft through that tube. As far as where we typically like to sample going through a hurricane, we're obviously very interested in the maximum winds in the eye wall. So you can see as we're flying through here, this is kind of a cross-section view of the storm. But we're looking to get those maximum winds on the surface in both sections of the eye wall, which is very challenging, and we'll kind of talk about that a little bit here later. And then obviously you can see the dropson pictured there. Falling in the center, in the eye, because we want to know what the minimum pressure is, and the Hurricane Center wants to know. And that gives an exact point as well, so they can put that in the models and begin to get a more precise and exact forecast. And
yeah,
Colonel Rickert, I'll let you kind of discuss here about the SFMR and how we look at visual surface winds.
Right. Thanks, Garrett. So, yeah, Garrett spoke already about the investment and how critical it is to identify what the wind speeds look like on the ocean surface of the water. And one way we are trained to visually detect what winds look like on the ocean surface. And we have a little chart, the meteorologists do. And basically what the ocean surface looks like, there's different categories and different ranges of what the wind speeds will basically give you. And you can get pretty accurate with your eyes after a little bit of training with some instructors of what it actually looks like. And then you also can detect which way they're going to, based on the basically the lines of the foam that's forming on the ocean and the different arcs of the wave caps and the wave breaking. So that's one way that we can detect if we are able to see the ocean. If we're not able to see the ocean, which a lot of times it's true, we have an instrument called the SFMR, the Step Frequency Microwave Radiometer, which is a really good instrument to detect high wind speeds. The low wind speed environment, it's challenging because there's a lot of other factors that may affect that wind speed, kind of like what Eric Blake spoke about 2 weeks ago. But as the winds increase, this instrument gets a lot more accurate. And it's really our bread and butter when it comes to Category 1 hurricanes up to Cat 5s. Now, there is some research going on at the high level wind speed categories just because there's not a lot of data with that respect, but it is a very accurate instrument when you're talking, strong tropical storms up to, the strongest of hurricanes. This is actually kind of an outdated picture. Garrett and I were discussing earlier, we've actually asked to get this updated. It's what the cone used to look like in 2004. And basically what it's saying is, for the amount of coastline that the data that we're providing to the Hurricane Center, we're able to minimize those impacts and those evacuations based on the data we're providing, because their forecast and their cone, they're able to shrink even more. They feel a lot more confident that the data they're getting from our aircraft and the models is a lot more accurate these days than it was 15 years ago. So now we really need to make this more accurate, because you've seen their cone, their track is getting very, very accurate. It's the intensity that we're still trying to work on and figuring out. But that track really can save copious amounts of money saved because of evacuations. It can save people's life and property based on the forecast. And you all probably heard from Director Graham and Eric and other people speaking about this, that it is critical, a critical piece of the information that goes into those models that makes it more accurate. A quick synopsis of last year. We kind of do this every year. Kind of gives you a perspective. If you're looking out in the central Atlantic, any storm that's really not impacting land, they either call a fish storm or a storm that's really not impactful to residents or people, life and property on land. However, they are very important because of all the ship traffic and the boat, people boating and whatever. So not to negate or degrade any of what the Hurricane Center is doing because we're not flying it doesn't mean it's not important. It's very important because of all those other things that are going on over the ocean. As you can see my mouse here, this was obviously our big one, Dorian. I think we ended up flying it for 10 days or so out of Curacao and then our home station. And then there were a few other ones, Barry, Fernand, a couple other small ones that I don't even think we flew Imeldo. Lorenzo was the one out in the Pacific that NOAA AOC actually flew, and they were able to get a lot of good data out of that. I believe they actually did a search and rescue mission for that one too. So just a quick recap, we flew 9 named storms, 8 in the Atlantic, 1 in the Pacific. That was a Lorena, and I believe we did 3 missions for that one that basically went up between Baja California and Mexico. So we were doing really quick passes on that one. 73 fixed missions, 7 invest missions that Garrett spoke about, those low-level missions, roughly about 680 flight hours, which is a decent amount. We average anywhere from 700 to 800. So we're just off that mark last year, and it was kind of a quiet year. And then I'll mention down below that 2008 to 2016, we had a really, really good success rate for that time period, about 8 or 9 years. Only 17 missed fixes out of the nearly 700 requirements levied against us. The last 3 years, we've had 35. And the reason with that, there's many different reasons and variables. Our aircraft are getting old. We had gotten the first C-130 fleet, or the 10 aircraft in the Air Force when they came out. So our aircraft are 20 to 25 years old now. So the maintenance is a lot more. There's a lot more small things that are happening that might prevent us from going out and flying a mission, just because, we might not be able to have the instrumentation to be able to do a hurricane mission or things like that. So I just kind of wanted to give you a perspective that our aircraft are getting old. I don't think there's any replacement right now, but if you do see a tasking for us and we're unable to do it, people might wonder, why aren't they doing it? Why aren't they doing it? Well, we have spares all the time too, spare aircraft. Sometimes we step to those and then they're broke too. So we make every effort to fly whatever we're tasked with from the Hurricane Center. Sometimes it just, things overwhelm us and we're unable to do it. And now Garrett's going to speak about his mission into Dorian.
Sure. So I'll kind of take you through. This was the Category 5 when it made landfall in the Bahamas. So I'll kind of walk you through what it's like for a crew member, specifically the RWO, the on-flight meteorologist, on kind of how we operate, what we're looking for, and just, I guess, what it's like from our perspective. And I'll show you a little bits of data that was obviously very significant during different passes through the storm. So this was the 28th flight into Dorian. That includes both Air Force and NOAA AOC. And we were alerted at 12:30 a.m. So on, I guess it would have been September 1st, just after midnight. And this is Central Time, just to kind of help you figure out how it works for our body clocks, if you will. But we were scheduled for a 3:30 a.m. takeoff. So obviously middle of the night, which those flights are always a bit difficult, I'll be honest, especially getting up at 12:30. Coffee and donuts are for sure rolling. But as we're going in, we call the National Hurricane Center as soon as we get into the office. And this was the relatively current satellite view from August 31st. And here was the initial forecast. So you can see it was at about 130 knots, which is a strong Cat 4 at the time. And they were projecting it while we were out there flying the storm to get up to 135 knots. So pretty much a top end Category 4 hurricane. So we knew it was going to be strong and a very powerful storm, but obviously we didn't quite expect what we ended up finding. So this is a Google Earth kind of overview shot of the entire mission off the coast of Florida and into the Bahamas. So you can see all these little colored barbs. You're actually able to find this and follow us on Google Earth and Tropical Atlantic as well. It's live data coming off our airplane. Every 10 minutes, we're sending out packages of our flight level information, and that's what you're seeing plotted there in the colors, the colored wind barbs. But at 6 a.m., we were turning inbound from the southwest of the storm. So we were getting ready to make our first pass through the storm. Once again, expecting a Category 4 storm, which is very strong. So don't get me wrong, we were definitely prepared that it was going to be a bumpy ride and whatnot. And then you can see here our first pass through, we ended up collecting 928 millibars at the surface from our drop zone in the eye of the hurricane. But if you want to go ahead and click to the next here, I'll kind of walk you through. So we ended up doing 5 center fixes during our mission. And I displayed here the different times. So you can kind of get the rhythm in which kind of it comes at us, if you will. So our first fix was at 6:32 a.m. Central Time. And that was there graphically shown at the 928 millibars. And you can see plotted the different pressures that we found and the exact locations that we fixed it. So it's typically an hour and a half to an hour and 40 minutes. We'll be back in the center of the storm. We modify that sometimes based on the National Hurricane Center request, whether they want to see more or less of a quadrant of a storm can kind of dictate how that time changes. But typically it's about an hour and 40 minutes through each pass of the storm. So you can kind of understand the rhythm there. But it was 6:30 a.m. to our last fix was at 12:43 p.m. So a little over 6 hours we were in the hurricane environment. And then you can see the wind speeds increase as well, the passes. So the first number is the surface winds, the maximum surface winds that we were gathering, and then the quadrant in which we found it. And then the second wind is the flight level wind. So you can see it gradually increases throughout our flight as it became a strong Category 4 to a very strong and historic Category 5 hurricane. So we'll kind of focus now on the fourth pass of the storm. This pass was when we recorded our highest SFMR values as well as flight level winds. You can see here, this graphic is, this chart is a product of Michael Brennan at the National Hurricane Center. So he did a study on the SFMR and kind of gave us a cross-sectional view of our data as it's coming in. So you can see the time here at the bottom. It's a little hard to see, but 1555 Zulu to 1700. So you're looking about an hour span as we're making that fourth pass into the eye. And graphically shown here is the red line is our surface winds that we're reporting. And the purple magenta color there is our flight level winds. So you can see, obviously, they spike very quickly once we get in the eye. So, or the eye wall, excuse me. So the hurricane winds were fairly large, the radius of maximum winds, but the eye wall was obviously very intense there. And it's a very sharp spike, which we'll talk about a little bit more as we try to get the drop zones to actually fall on that exact maximum wind. And then how rapidly it drops into the eye, of course, where the winds are very calm. But we recorded 177 knots at the surface. And real quick, I want to show on this chart as well from a time perspective. So you can see, let's say 1615 Zulu, you can see the winds really start picking up when we're going inbound into that eye wall. And by, let's say 1630, they start to finally calm down going on the out of the eye wall, outbound. So it's a 15-minute window where we're flying through both eye walls and we're trying to find the location of the center of the eye. So from a task saturation standpoint, the weather officer and the whole crew, we are very busy during this 15-minute portion of a flight. It's all the work kind of getting jammed into a very small window of us trying to make sure that we get all the data possible and the most accurate data. So I'll kind of walk you through what these charts are. They're a bit obscure to just look at, glance at the eye here, but I found these a very interesting and a way to show kind of how difficult it is to find the placement of the strongest winds at the surface in the eye wall. So if you look at the blue line here, starting at the top left, that is the altitude in which the dropsonde's at. So towards the top there, that's when it's leaving the aircraft. And you can see it gradually slopes down to the bottom right side of the chart there. And that's when the dropsonde hits the surface. So it's falling down over time. That's what that's depicting. But I really want to focus on the red line here. And that's the winds that the dropsonde's reporting as it's falling. So once again, on the far left, that's 0 second, if you will, from when it's being released from the aircraft. And then on the far right side, in red, is when it splashes at the surface. So you can see the winds are strong at flight level and higher up, but as they start getting lower and lower into the planetary boundary layer, is what we call it, the winds are very strong, over 180 up to 190 knots, which is well over 200 miles per hour. That's not the surface, but it's just above the surface, and a lot of times that gives good indication to the National Hurricane Center, the severity, intensity of the storm. And then the last dot there on the far right in red, that's the surface wind that the dropsonde reports. So if you notice here on the graph on the left, that's 156 knots at the surface. And 5 minutes later, we released one on the inbound leg, so 5 minutes earlier, you can see how far that red dot on the line drops off on the right image there. And you can see we had a very strong winds, but we only reported 58 knots at the surface on that dropsonde and the eye wall within 5 minutes of each other. And as what's going on there is more than likely, I released the dropsonde a little bit late in the eye wall, and it ended up getting pulled into the eye a bit. And that's why you see those winds drastically drop to 58 knots, which is still strong, but it's way different than 156 knots. So it's a matter of seconds of releasing that dropsonde to get those maximum winds. So it's definitely a challenge for us to try to really isolate that. And this is, once again, those same two dropsondes imaged here on the right and left. And this is the latitude and longitude, the latitude being the y-axis and the longitude being the x-axis. You can see how far these sondes move. So, of course, they're not going to fall directly to the ground when you're experiencing anywhere from 150 to 200 plus mile per hour winds. So you can kind of see how far they move. It's a little bit tough to understand in miles on this graph how far they move. But for example, those sondes are moving about halfway around the eye into in a completely different section of the eye wall that we're actually flying over. So they are hooking and moving and flying counterclockwise right along those winds of the eye wall. And this one shows a little bit more on kind of how far they actually travel with the map view. So this is right after our final fix, the 5th fix into Hurricane Dorian, where you can see we had 912 millibars measured by our drop sonde. And so if you can follow that faint little red line exiting the 920 millibars to the northwest there, I have that yellow point, the 1741Z drop release point. So that's where we released the drop sonde. And this is the one that unfortunately got pulled into the eye and missed the maximum winds. You can see that's where we released the drop sonde, where we felt the northwest eye wall maximum was. And where it landed was, if you follow that second, this drop splash marking down there, it's well south of the where we fixed the storm there below the 912 millibar. And as the crow flies, it was 11.3 nautical miles is how far that drop sonde traveled in about 4 minutes time. And it actually traveled a lot further because it actually hooked and arced around, flying counterclockwise around the eye wall. So it ended up probably going well over 15 nautical miles in the air. And we released it from a mere 10,000 feet, which is just about 2 miles off the water. And so it was traveling way more horizontally than it was falling vertically, if you will. And this is just kind of a numerical graphic of those 2 drop sondes, once again, the left and right. So I tried to keep them the same so you can see the data in different ways. But once again, if you look at the top line there, that's the surface reading. So you can see the 156 knots or 180 miles per hour on the one that we actually hit the maximum winds. But keep in mind, these are instantaneous readings. So there is a lot of ebbs and flows that go with it, whether there's a strong gust, whether it falls in the crest of a very tall wave. Obviously, these waves were probably many tens of feet high. And so if it kind of falls in a lull, it may not pick up the strongest winds. So it's just one piece of data the Hurricane Center can use. It's not to be, specifically used just for the intensity of a hurricane, but it kind of gives an idea of what the environment may be out there. And this is courtesy of the NOAA P3, a radar imagery that they're capable of collecting and sending off the aircraft to the Hurricane Center. And this was about 2 to 3 hours before those drop sondes that I showed earlier. So this was earlier into my specific flight, but you can see the storm is obviously a Category 5 at this time as well. It's very strong. So you're looking at a cross-section view of the storm, looking at the vertical profile that the NOAA P3 was able to collect. And you can see in the purple colors, that's the hurricane strength. And then the brighter magenta there next to the big white empty blank, that's obviously the eye where there were very low wind speeds, which you would expect. So you can see that the gradient gets very sharp for those maximum winds right by the calm eye. And here's just a few images that our air crew, this is actually, we had a couple Navy individuals on board with us releasing buoys out in front and into the storm environment. And they were able to take some of these photos as we were flying through the eye. So you can see the stadium effect. It was absolutely beautiful, to be honest with you. I'd never seen anything like it. I mean, it was very vertically stacked. So it was just like a big wall or stadium of those clouds going around. And you can obviously see the sun and the clear skies above. And there were a few lower level clouds in the center of the eye that you can see swirling around down there. But one thing I'll remember, and I'll probably never forget, to be honest, is I've never seen, it's hard to depict how big the waves are when you're 10,000 feet in the air, but I'll never forget seeing the amount of swirling. It looked like a giant washing machine down there. There's absolutely calm waves right in the center of that. And then you go barely 5 miles, and it's hard to understand how large the waves are. But I've never seen anything like it. It was absolutely massive waves, and that was from 10,000 feet. So I can't imagine what it would have looked like from a lower altitude. But the waves were all swirling and going in a circle, if you will, around the actual center of the storm. And so it legitimately looked like a giant washing machine just throwing massive waves. And it's a sight that's very hard for me to put into words and explain, but it was definitely very memorable. And this is just a radar image of what it looks like from our radar as we're going through the storm. So you can obviously see the eye wall there, and then the center of the of Hurricane Dorian there. So we use that once again, the navigator, to kind of try to keep us safe from the worst weather. But it's obviously a very useful tool for the weather officer on board to kind of understand when we're going to see the maximum flight level winds, and kind of keep just a good situational awareness on where we're at in respects to the storm. And so to kind of cap off what it was like for the crew and what a mission entails for us, we ended up landing about 3 p.m. Central. So we took off about 3:30 a.m. in the morning. So it ended up being about a 12-hour flight, with 6 of those hours in the Category 5 hurricane environment, up all night. So as you can imagine, it's a very tiring, exhausting, adrenaline-filled, emotional day, really, especially with the landfall. So there's just a lot of different things kind of going through your mind, and you're exhausted, and it's a very unique situation and feelings, to be honest. But you can see we ended up spending about an hour on the ground after the flight, doing post-flight mission briefs, maybe giving the Hurricane Center a call, and once again kind of doing a follow-up on what we saw. So it ended up being a 15-hour workday. And the big thing I want to emphasize is it's a 15-hour workday, but oftentimes if there's a lot of storms in peak September, we have to go what we call an immediate crew rest, and we have 12 hours to go home, sleep, and eat and try to calm down from that before you're going out on another mission like this at a different time throughout the day. So it gets very exhausting. It can get very exhausting for not only the operators, but for maintenance as well, because they're going through this kind of cycle as well. So it's a lot of adrenaline and a lot of different things that wear you down, especially in the heart of September during peak hurricane season.
Hey, thanks, Garrett, for that pretty comprehensive view of your mission in the Dorian. I flew the MAX flight on Irma as well, and just to give you a quick picture of what it's like up in the cockpit or the flight deck going through that eye wall. I'm going to hit this. There is a little sound, so it might be a little loud. This is our pilot basically trying to keep the plane level. And then you have the co-pilot that's trying to keep the speed at 180 knots of our aircraft, so that way we don't stall or get too fast. So I'll just put this on for a few seconds just so you can kind of see. And you can also see this rain and the intense rainfall hitting the windshield. Sometimes we get because it's not often, because it's a warm core system, but some of the more intense ones, we do get that. And now you can kind of see he's trying to keep that plane stable. And, it's a couple minutes actually that you're going through that really intense part of the eye wall of the storm. And then this next one is one of the awe moments where we all, in these really big storms, we get to watch as we're kind of going through that eye wall, and then we break out into a Cat 5. This is where you like out. This is a picture from Irma, very similar to what Garrett had for Dorian, that stadium effect inside. Now I'm going to transition to just a little bit of what we do. A lot of people wonder, what do you do outside of hurricane season? Well, as you can see here, that's our NHOP season. It runs from June to the end of November. This time of year, we do a lot of air shows and awareness where we take our airplane and our crews out. We share with the general public on why we do what we do and why is it important, and then kind of give them the hazards, and to really listen to their local authorities and the emergency managers of why that's important to listen to what they're saying. This time of year, we have to calibrate some of our equipment, so we were able to do that very effectively during this downtime during the pandemic. We were able to calibrate all of our SFMRs, which we have to do every year, which is a lot of work. We have 15 of them, so we have spares that we have in case one of them breaks. The search and rescue is just, it happens occasionally while we're in a hop. If there's a boat that's missing or things like that, we will respond to those if we're asked. The one thing I'm really going to focus on the next few slides before we finish up is the winter season operation plan. The NWSOP runs actually November through the end of March. But really, we don't see a lot of action until after the new year. And then just some generic airlift things we do throughout the year. We have an Aeromed squadron here. We allow them to set up in the back of our airplane and train as if they're actually deployed and evacuating medical personnel, or actually injured, or people that are injured from downrange. But the big thing, atmospheric river missions, I just wanted to talk briefly about this. We've been doing this for the last 4 to 5 years. Much different than NHOP missions. We fly high altitude, so we're trying to drop sondes in targeted areas over the ocean, collecting as much data from our aircraft down to the surface of the ocean. So we're up 30,000 feet a lot of times. As you can see, we have the NOAA AOC partners with flying the G4 high altitude, flying out of Portland. Typically we'll fly one out of Hawaii and one out of California. And these atmospheric rivers are low level moisture fluxes down near the ocean up to about 700 millibars, 10,000 feet, where we're trying to collect all that data from our drop sondes and sending that off, ingesting into the models and sending it to the researchers to really figure out how it's impacting that, because it's very difficult to forecast where these atmospheric rivers are making landfall on the West Coast. And it's critical for the forecasters and the reservoir managers, the people that are managing the water out there, on focusing on where it's going to make landfall because they're very narrow bands of moisture. If the reservoir managers are able to hold water in and collect as much based on where the forecast is being improved on, they're able to save more water throughout the year rather than letting them out because they think it's going to be a big flood, and it turns out to not pan out that way because the forecast was wrong. So that's really why we're doing it. This is a glimpse of what we did in 2019. A couple aircraft out of Hawaii or out of California, single missions, one out of Hawaii, one out of the West Coast. And those colors, the red, of course, keeps moving on me. Red is the most significant moisture transports. Really, really, basically the Pineapple Express that's, being transported from south of Hawaii up and going into the West Coast. So the lighter colors, not as intense or not as much as moisture, but the darker colors, really, really intense storms that are going to hit the West Coast. This is a really good impact slide. All those red dots are the drop sondes from the 3 aircraft, 80 drop sondes. Equivalent to the upper air network. It's basically 3 times the amount of drop sondes in the upper air over that area, but it's comparable to the entire network, the impact on the model. So that one time that we go out and we drop all those drop sondes, 80 of them, is comparable to the entire North American upper air sounding network. So just to basically tell you why it's so important, because that impact of the drop sondes are more or as impactful as all the upper air soundings that are going on in North America. Just a few pictures and stats. As you can see, we started out 2016, 3 missions, and we did 12 this past year. The goal next year is up to 24 potentially, and our increase in drop sondes that we've been doing. And our flight hours, of course, is going to increase as we do more storms. That's just a picture of the back of the aircraft, dropping the buoys out of the aircraft or getting staged to do that. And, a picture of what it looks like over the ocean and our aircraft taking off out of Portland. So the last 2 slides that I'm going to brief, and Garrett, you can chime in too, we've been really expecting some upgrades. Our computers, it just takes so much stuff, so much. It's really frustrating to talk about how much time and effort it takes to upgrade stuff on our aircraft because we don't own our aircraft. So some big ones that we're really expecting this year is we're hopefully transitioning from Windows XP over our weather officer computer up to Windows 10. We're hoping to get that in the middle of the season this year. Some new big, more robust monitors, an upgrade to our SFMR software to be able to be compatible with Windows 10, and then also getting rid of some of the known delinquencies in the software. And then we really have a problem with data storage, or we have these hard drives where we have to transfer it, and a lot of people use our data. So we're trying to get an archive of that so it's able to be readily accessible right after our flights to transition to the hurricane researchers, NCAR guys that are actually looking at our drop zones to make sure they're functioning properly. And many different entities are looking at that stuff. And then moving on into the future, there's a lot of high hopes, of course, upgrading our satellite communications that we are able to talk to the Hurricane Center, our basically our liaisons called CARCA there, upgrading our SFMR software again, potential high altitude AXPT launcher. These buoys that we drop out from the Navy out of our aircraft, they're only able to be done at 10,000 feet, but with this high altitude, we'll be able to drop it for winter season plan or winter storms as well. We don't have the capability of sending off radar imagery and having Wi-Fi on the airplane right now, but the goal is 3 to 5 years down the road. Hopefully we'll have that. Potentially a 360 radar or a skin radar on our aircraft, which gives you a much higher resolution, similar to what the P3 has, and then updating our mission manager software. And then the transition to the last one, I wanted to touch a little bit about, I know a lot of people have questions about how COVID-19's impacted our squadron and our readiness. So I kind of have it broken down into negative and positive impacts. The negatives, we've really significantly reduced our flying over the last 2 months, really down by 75%. So 2 flights a week, which have been strictly for calibration flights and getting students upgraded training. We've all experienced the travel restrictions for hurricane hunters. So we have half of our squadron is part-time, and most of them live outside the area. So they've been restricted to travel, come here, flying, currency, proficiency. So that's been somewhat of an impact. And then currency and proficiency for our normal full-timers with the lowered amount of flights that we've been flying over the last 2.5 months too. All our awareness, conferences, networking opportunities for the meteorologists and air shows has been basically canceled for the entire spring. So that's a huge opportunity for us to be able to share awareness on what we do and why we do it to the general public. And then the last thing, it's going to be really tricky forward deploying to St. Croix in Hawaii and California and different locations as we start flying to provide support to the National Hurricane Center. So we're really kind of working through that, how that's going to be put into effect. Is there going to be quarantines put on personnel, those types of things. But there has been some positives. I would say the one thing, I'm going back to the last 3 years, we've had a lot of maintenance issues with lack of manning and our aircraft. Maintenance has really been able to work hard on our aircraft the last 2 to 3 months because it's been very limited flying and going on cross countries in different locations. So we've really, over the flights that we've had very minimal impacts and very minimal things go wrong with our aircraft. So that's been a huge plus to us, and hopefully that'll last throughout the year. It's really minimized the exposure to the pandemic and the COVID-19 impacts, to personnel. We have funding issues every year. However, this year I haven't heard a peep about money and lack of money or anything like that. So I would say that's kind of a plus. And then we've really been able to focus on some of these projects, these contracts, and be able to upgrade software, things like that. We've been able to, I know I've been really involved in upgrading or updating winter season plans, integrating new concepts of operations and different techniques and things like that we're going to employ for this upcoming winter season plan. And then projects for upgrading our softwares and things like that too. So with that, this is Garrett and my contact information. If people have questions or want to reach out to us on Twitter or Facebook, kind of turn it over back to Alex and Tim and Bill.
Thanks, guys. That's a terrific presentation. A lot of great information there. The most common comment that's coming in on Facebook is thank you for what you do. People really appreciate the work that you guys do, and so that's been a number of folks just thanks, and thanks for explaining it in a way that they can understand. Couple of questions. Lee Harbison wants to know is how do we follow you on Google Earth? How can we follow you?
Right. Well, so on Google Earth, usually it's a data package that Colonel Rickert, do you know where you can get that exactly? I know on the archive how to do it.
I know. I think it's a layer. I think you have to add on Google Earth, and we'll have to send that out to you so you can pass it out on. I'm not exactly sure. I think it might be a file or a layer that you add.
Okay. And I know
you can open up Google Earth, and then it basically plots our stuff, and you're basically tracking. I don't know if you know, Bill, how to do that. If not, we can get that out to everyone.
Or Tropical Tidbits is another great site that I know. I believe Levi Cohen is the one who runs that and built that. But that's a very useful site that I know we use a lot to kind of follow each other as well. So it's a great site, Tropical Tidbit.
That's right.
I think Tropical Atlantic you actually can follow on Google Earth. I think there's a way to click on the Google Earth icon, and then that'll basically pull up our data, and you'll be able to track it that way as well on the specific mission that we're flying that day.
Terrific. Kelsey Carpenter asked the obvious question: do you guys ever get scared?
From my perspective, I don't think scared. I think there's different times that, especially when you're getting ready to go into a storm like Category 5 Dorian, that you definitely are more aware of what's going on. It's definitely a heightened sense, but I don't know, personally scared, but I don't know, maybe Kelsey would feel different. But how about you, Colonel Rickert?
I would say maybe my first Hurricane Matthew, I was a little nervous because that was the first missions I was flying without an instructor and tell me, basically catching my mistakes. And for all you, I'm going to let the cat out of the bag. Kelsey Carpenter is also a hurricane hunter, so he's just trying to put us on the spot.
It's good to have planted questions, that's all right. but you've got 6 hours of buildup as you're flying into these things. Sometimes you get 6 hours or 3 hours of nothing, and then boom, you're there. A lot of anticipation and a lot of time to think about what you're about to fly into.
Sure. Yeah, and sometimes that can play to your advantage, though, because you have more time to kind of prepare and get your ducks in a row, if you will. But it also is more time that we're away from instant data and seeing satellite views and whatnot. So the storm can change during a longer duration of en route. So, but that's why we have capability to talk to the National Hurricane Center, and they can kind of give us live updates either through the text that I talked about earlier, or even our sat phone, and give them a call. So.
That's right.
Bill, jump in here. I know you've always got a handful of questions, so go ahead, Bill.
Oh, great talk, guys. First thing, a plug for your invest. Those are vitally important, and I know in the broad sense they're not exciting to the media because there's not a lot of big stuff coming out of them, but frequently just from satellite we'll be way off on some of the initial conditions. So getting that best data to initialize the models is critical. So kudos on keeping the Genesis phase going. Now, when I flew, I had a problem with motion sickness, but every storm was different. How turbulent was Dorian?
It was definitely bumpy, but I wouldn't say it was the roughest ride that I've experienced. And that's kind of an interesting thing, because a lot of times for the strong storms like that, you'd expect it to be the bumpiest, and then it ends up being, moderately bumpy. It still throws you around a little bit, but a lot of times it's the storms that you'd least expect, whether it's a tropical storm that's kind of going through some kind of decay or rapid intensification. A lot of times those are the ones that are actually the bumpiest. But Dorian was definitely bumpy, but I wouldn't say it was in my top short list.
Wow. Yeah, they're all different. I remember one of your colleagues from 2007 gave a similar talk on Felix and how it's the roughest ride he'd ever experienced.
Yeah, it's definitely interesting when you get one of those and you don't forget.
Yeah, on the time frame on the radar, and do you have any horizon on that? And is it going to be Dopplerized?
That's a challenging question. You should. I know that they've been looking at it, and there's some new developments on different types of radars. I think honestly, it's a ways down the road, just because there's so much stuff. Like once you decide on what it is, then you have to go through like getting the contract and who's paying for it and how much is it going to cost and are we putting on all 10 of our aircraft and then testing it, making sure that you're able to go through that environment without, destroying that piece of equipment. So there's a lot that goes into getting something new on our aircraft versus the NOAA AOC. They're basically the test bed. They put the stuff on. It's a lot less bureaucratic tape that they have to go through to get it on their aircraft. They test it, make sure, and then we're the operational aspect of it. So it should be able to be a seamless transition, but it's not because, DOC versus DOD and different contracting pieces and things like that. So honestly, I could give you a number, but we've been expecting an upgrade on our Windows computers for like 8 years now, and here we are this year just getting it maybe. So
okay, yeah, in a perfect world, you mentioned the aircraft, they're aging now. In a perfect world, we design you 10 new aircraft, build them from scratch, designed for flying weather, and that way it would work better. So these guys can't lobby for that. So all those of you that are listening, lobby your emergency management, local officials, all the way up through Congress, and maybe you'll see something.
okay.
Tim, back to you.
Yeah, I think that's fascinating. It seems like the weakest link is the aircraft itself, and there's any hope of anything anytime soon to solve that link. No answer. I like that. That's safe.
Was that a question?
I let Colonel Rickert handle the equipment. That's above my pay grade.
Yeah, well, it's a very expensive proposition, and it's your mission is not viewed by people not involved in the thing as part of the core Air Force mission. So it always is a challenge you have to argue to Congress for the stuff you need.
Even though I'm a lieutenant colonel, that doesn't mean anything. I'm a worker bee, basically. I'm not in any position of authority, when it comes to our now equipment. I do have a piece for the SFMR. So I will say, like, some of these upgrades that we're doing, the contract that we got approved this year, I mean, it's a decent amount of money that we got this approved, and we're working through getting that upgraded this year. And then the next one in like a year or two, that's going to be another decent amount of money. So I do have some influence in that. However, outside of like putting stuff on the airplane, not really my cup of tea.
Well, gentlemen, thank you. We appreciate your time. Fascinating presentation today. A couple of people saying hello. Lou Fisher says hi from Houston. Nick Morganelli says get to New England so we can get together soon. So great audience today. Thank you, everybody, for sending in the questions. And Lieutenant Colonel Rickert, Captain Black, thank you so much for your time. We appreciate you always being there for the National Tropical Weather Conference. We look forward to seeing you in person soon.
Yes.
Absolutely.
Thank you.
Thanks for having us.
Get it.
All right, guys. Bill, thanks always for your work and emceeing this thing and having great questions always, Bill. Good job.
Thank you.
All right, that's it from this end. Alex has got some stuff that's coming up in the future. We've got a lot of great presentations beyond this. Usually 10 o'clock in the morning we're here. Alex, what else do we have coming up?
All right, we've got some really good ones coming up. We just finished up, of course, this week with Ken Graham, and, of course, you just heard from Lieutenant Colonel Ryan Rickert and Captain Garrett Black. Coming up next week, it's the Hurricane Man himself, Josh Morgaman. Josh was out there in Dorian, and we kind of lost Josh for a few days, so he's got an important, exciting story. You'll hear it right there from Ground Zero. Then